In this video, we're going to add vectors. A plus B equals C. Vector A plus vector B equal vector C. What is C? Let's look at what A and B are. So A, we're going to do everything in 2 dimensions here, so we're just looking in the x, y plane. So I'll write A as its x component, AX, I hat, plus AY, J hat. AX is the x component, AY is the y component. AX and AY can be positive or negative. They could be 0, therefore there'd be no component in that direction. And I hat and J hat are the unit vectors, so they point 1 unit along the x direction for I hat and the y direction for J hat. Similarly for B, we have BX, I hat, plus BY, J hat. When we add them, we add components to components. AX plus BX, I hat. So CX is AX plus BX. CY is AY plus BY. So this gives us everything about C, although we can repackage it in different ways. In other words, we can find the magnitude of C, and we can find its direction with respect to one of the axes as well. But all that information is given in its components. Let's take a look at some examples. Here's A is 2I minus 3J, and B is minus I minus J. C is A plus B. What is C? C is AX plus BX. We have 2 plus negative 1 is 1. I don't write a 1 out in front of the I hat. Just write the I hat. The 1 is implied. Then I have minus 3J minus J. So we have negative 3 plus negative 1 is minus 4. J hat. And again, I don't write plus in parentheses negative 4. It's understood I hat minus 4 J hat. All right, given that C is I hat minus 4 J hat, let's find its magnitude. The magnitude of a vector, we'll just do it in general, is x component squared plus y component squared. We're dealing with the 2-dimensional vector. So we have cx squared plus cy squared. In the particular case of interest here, cx is 1. So we have 1 squared is 1. And then cy is negative 4. We take the square root. 1 squared is 1. Negative 4 squared is 16. So we get the square root of 17. So the magnitude of C is 17. And it extends 1 unit in the x direction and 4 down, or 4 along the negative y. So we can find its angle, for example, with respect to the positive x-axis if we'd like. Let's plot these things. All right, so here's a grid. Let's put A down, which is 2I. So it goes along 2I and then 3J. So it is here. If we can draw an arrow toward, this is A. That's A. And then B is minus 1 in the x direction, minus 1 in the y, because it is negative I hat minus J. So it then points here. That's the vector B. And then we saw that C is equal to I hat minus 4 J hat. So it's I hat, pick, so I, 1, and then minus 4. So it's here. So this is C. So C then is is I hat minus 4 J. We can see the magnitude of C is square root of 17. And if we'd like, we could find the angle, C, with respect to the x-axis. The reason is we have this triangle of magnitude 17. Let me just draw our C triangle here. Right? So I'm just drawing the triangle C. I'd like to find this angle theta. It has a hypotenuse of 17. Just drawing the magnitudes of the lengths of the sides of this triangle, 1 and 4. Therefore, we could find theta by looking at the cosine, for example. So the cosine of theta is 1 over square root of 17. So we take the arc cosine, or the inverse cosine, of 1 over square root of 17. And I found that this is about 76 degrees. So it's 76 degrees below the positive x-axis with a magnitude of 17. So notice whenever I was finding the angle, I just wanted to deal with +1, +4. I wanted to deal with all positive sides so I could just nicely take the cosine, because I had in mind that my angle is the angle below the positive x-axis. You could say, all right, it's the angle counterclockwise here, right? So we take then 360 and we subtract off 76, so we get about 284 degrees counterclockwise from the positive x. But it's just as good to say our vector c has a magnitude of 17 at an angle of 76 degrees below the positive x-axis, because c is equal to I hat minus 4 j hat. So that's how we add a and b. Let's look at another example where a minus 2b is equal to c. Again, a is 2 I hat minus 3 j hat, and b is minus I hat minus j hat. Therefore, 2b is minus 2 I hat minus 2 j hat. Each of the b components is multiplied by 2. Therefore, a minus 2b equals c. Let's write c then as a minus 2b. So we have 2 minus negative 2. You get 4 I hat, adding the x components to the x's. And then a, so minus 3 minus the negative 2. B, we get then minus j hat. Therefore, the magnitude of c is the square root of 4 squared plus minus 1 squared. So again, we see that the magnitude of c is the square root of 17, and it points 4 units in the positive x direction and 1 unit in the negative y direction. So let's then see what this looks like on our xy plane. Okay, so we have a is 2i minus 3j. So we go over 2 and down 3. Here's a. So a is here. B is minus I hat minus j hat. So this is B. And then negative 2b, as we saw, then is plus 2 I hat plus 2 j hat. So it actually sits up here. So then this is negative 2b. So a minus 2b, we saw is 4i hat. So we go over 4 in the x and down 1 in the j. So this would be a minus 2b is here, and that's c. Again, the magnitude of c, the length of the hypotenuse is square root of 17. We could find this angle theta by looking at the inverse cosine of 4 divided by square root of 17, the inverse cosine of that. Let's take the inverse cosine of this. Inverse cosine of 4 square root of 17. And you get an angle which is about 14 degrees. And this makes sense because earlier we saw, in our previous example, we found that angle, which was 76. So 76 plus 14 is 90. So our C, which is A minus 2B, has a magnitude of 17, and it points at an angle of about 14 degrees below the positive x-axis. To summarize then, given A and B, if we add them up, we get the resultant vector C, and the components of C are Cx is Ax plus Bx, Cy is Ay plus By, and we can of course find the magnitude of C as the square root of Cx squared plus Cy squared, and then we can also find the angle with respect to whichever axis you would like. So now we understand how to add vector components, and so we can add the vector components, we can find the resultant vector, and we can determine its geometry, its magnitude, and direction as well.